So this question 10 is about the quadratics formula. So first of all, I will write down the quadratic formula here. So the quadratic formula is x equal to minus b plus minus b squared minus 4ac square root over 2a. So this is the quadratics formula. And then we have quadratics equations ax squared plus bx plus c equal to 0. Okay, so we have a quadratic equations in this form, and then you have to know what is your a, what is your b, and what is your c, and then you use this formula, you substitute the values of a, b, c accordingly, then you can get the x values. So let's take a look at question 10a. Okay, question 10a. So what happened here is we have x squared plus 6x plus 3 equal to 0. So for this case, a is equal to 1, b is equal to 6, c is equal to 3. So we have 1, 6, 3. And after that, to find the x value, so we use the quadratics formula, minus b plus minus square root b squared minus 4ac over 2a. So x equal to minus 6 plus minus. Okay, so this is going to be, okay, so let's continue. We have to press calculator for everything in the square root. So we get square root of 24 divided by 2. And now you have to separate them into two equations. So the first one take positive square root and the other one take negative. So like this. And normally we change them to decimal numbers. So minus 6 plus square root 24 divided by 2. So we will get negative 3 plus 6 in decimal. This is negative 0.5505. So the other value, minus 6 minus square roots of 24 divided by 2. So we get minus 3 minus square roots of 6. In decimal, we get minus 5.449. 4495. Okay, let's say I put it in 5 decimals. Okay, so that is the first question.
Why do you put it in the 5 decimals?
4 decimal, let's say. So the question never mentioned how many decimal they want. So let's say I just fix it as 4 decimal places. 5505, this is 4495. Yeah, so of course it depends on the question also. The question will mention how many decimal or how many significant figures they want. Okay, so then let's continue. We look at b then. We have x squared plus 9x plus 12 equal to 0. Okay, so for this case, our a is 1, b is 9, c is 12. So we use the quadratics formula again. X equal to minus b. So minus 9 plus minus 9 squared minus 4ac square root over 2a. So again, we press everything in the square root. So we have 9 squared minus 4 times 1 times 12. So
they put it into square root. Why?
Sorry?
They put it into square root form. Why?
Uh,
Is that just because they follow the formula?
yes, it's because of the formula. We follow the formula. This is the formula.
Yeah.
So we just follow, we substitute accordingly, and then we simplify that. Okay, and let's see. Now after we reach here, then we can separate them into two parts. The first part we take positive square roots of 33 over 2. The second one we put like this, over 2. Then, okay, let's simplify this. We get negative 1.6277, or minus 9 minus square roots of 33 divided by 2. So for this case, we get negative 7.3723. So these are the answers. And then we continue with C. Question C, we have x squared minus 4x plus 2 equal to 0. So for this case, A is equal to 1, B is minus 4, C is equal to 2. So we use the formula again, x equal to minus B plus minus B squared minus 4AC square root over 2A. Okay, so we use the formula and we get something like this. So again, we simplify everything in the square root. So basically we have 16 minus 8, so which is square root of 8 over 2. Okay, then we separate. Okay, before we separate, let's simplify it first. So after I simplify this is supposed to be 2 plus minus square root 2. Okay, then I will have x equal to 2 plus square root 2, or 2 minus square root 2. Okay, so then we change it to decimal. We have 3.4142. 2 minus square root 2, so we have 0.5858. Yeah, so this is C, the answer for C. And let's continue. We have D then. Question D, 2x squared plus 7x plus 2 equal to 0. Okay, so for this case, A is equal to 2, B is equal to 7, C is equal to 2, x is equal to minus B plus minus B squared minus 4AC square root over 2A. Okay, so we have this, and again we simplify everything in the square root. So we have 7 squared, which is 49, minus 4 times 2 times 2. So we have square roots of 33 over 4. And then we separate them. One part positive, another one negative. Okay, then
you do that because do you actually have to do that, or can't you just write down the same, like plus minus?
Plus minus together.
You split it up. Why can't you just do it together?
We need to split it out because later, right, as in here, you see, if you end up with two different answers, so that's why we have to split it out and count separately. It will be two different answers. So likewise,
you need those two different numbers so you can plot the graph, or
once we have these two values, so of course we are not going to plot the graph. These two values just means that there are, let's say for example, let's say for this case, for C here, so once you get these two value, right, so it's actually means the two values on the x-axis. So it's something like this. There are two value on the x-axis, which is 0.5858 and 3.4142. Two values on the x-axis. So it's something like this.
okay.
Yeah. So it represents the x-intercept actually. So we are finding that.
But then,
Yeah.
so then the middle point is the midpoint.
Yeah. If you want to find the middle point, so you add up these two and divide by
Then you
2.
just use.
Yeah.
Yeah. Okay.
Yeah. That will be the middle point. Okay. So let's continue with this here. We press calculator, and for this we get negative 0.3139. The next one we get negative x equal to negative 3.1861. Okay, so these are the two values that we get. Both are negative. Now let's continue with E then. Question E. So we have 2x squared plus 7x plus 4 equal to 0. Okay, so for this case, we have A equal to 2, B equal to 7, C equal to 4. Okay, then we have x equal to minus B plus minus B squared minus 4AC square root over 2A. Okay, then 7 squared minus 4 times 2 times 4, square roots of 17, square roots of 17 over 4. Okay, then again we separate them, minus 7 plus square roots of 17 over 4, minus 7 minus square roots of 17 over 4. Okay, then now we press calculator. Okay, so the first one we get negative 0.7192. The second one minus 7 minus square root of 17 divided by 4, so we get negative 2.781. Okay, so these two are the answers. Okay, now one more. Let's look at question F. Question F, 3x squared. Question F, 3x squared plus 9x minus 1 equal to 0. Okay, so for this case, we can see A, B, C again. A is 3, the first number. B is 9, and C is negative 1. So again, yeah, we use the formula. Okay, the formula minus B plus minus B squared minus 4AC over 2A. Okay, then and we count everything in the square root first. So we get minus 9 plus minus square roots of 93 over 6. Yeah. Then after that, we separate them into two parts.
Okay.
Okay, then we count this. Minus 9 plus square root of 93 over 6. So we get 0.1073. The second one we get negative 3.107. Okay, so these are the two values. Okay, so that's already for these questions. Okay, so now let's continue with question 11. Find the equation of the quadratic and the graph of which is shown. Okay, so you can see the graph here. This is a quadratic, a parabola. So they give us a point, then they give us the x-intercept. Okay, the x-intercept are 0 and 5. So what we can do here is, the important information here is the 0 and the 5. So we know the roots, then we can put it in the factorized form. So something like this, 11. So we can use y equal to a. So the roots are 0 and 5, so we can put x minus 0 and x minus 5 basically. Okay, so we put it in this form. And of course, if I simplify this a little bit, it will be a x minus 5. Then after that, we can use the point here, 6, 10. Okay, we can use this point, 6, 10, to find the values of a. Okay, so use 6, 10, and we substitute in this way. The 6 is the values of x, and then 10 is the value of y. So we put 10 here, 6 here, 6 minus 5. Then we count it, 6a times 1 is still 6a. So we get a equal to 10 over 6, which is equal to 5 over 3. Okay, so we get this. So once we get this, then we put it back to the equation. Y equal to 5 over 3x, x minus 5. So you see I put into the second equation there. And after that, we expand it. We times this with this. Then we get 5 over 3x squared minus 25 over 3x. So that is how we get the quadratic equation for question 11. And now let's see question 12. Question 12. So what they give us, they said parabola has the same shape as y equal to 3x squared, but its vertex is at 5, 2. Find the equation corresponding to this parabola. Okay, so I try to draw it out to let you see what happened here. Okay, so if I draw it, y equal to 3x squared is actually like this. Y equal to 3x squared. Okay, now they said we have another parabola with the same shape, and its vertex is at 5, 2. So the vertex means the minimum point. So for y equal to 3x squared, the vertex is at origin. But now the vertex is at 5, 2. So 5, 2 is somewhere 5, 2. Okay, so somewhere around here. Okay, so 5, 2. And then it has the same shape with that actually. It has the same shape with y equal to 3x squared, but just that the vertex is there. Okay, so we have to find the equations of this parabola. So what to do is we need to do translation or transformation. So we have to move our red color graph 5 units to the right and 2 units going up. So to move it to the right and move it upwards. Okay, so to move the graph to the right, so the quick revision here, if you have y equal to something, to move it to the right, so you have to change it to y equal to fx minus 5. That will make the graph to the right. And after that, to make the graph going up by 2 units, this is 5 to the right and 2 going up. So to make it going up by 2 units, so we had to plus 2. We had to plus 2. Okay, so now let's do it here. For our original quadratic, which is y equal to 3x squared. Now in order to move it to the right, so it becomes y equal to 3 x minus 5 square. And in order to make it going up, you have to plus 2, so it becomes 3 x minus 5 square plus 2. So that is the answer. So the answer is this one. Y equal to 3 x minus 5 square plus 2 is the equation that represents this point. Okay, so that's question 12. Now let's see question 13 then. Question 13. So I do it here. 13. Find the values of m if 2m minus 3. Okay, I write down the equation at the same time. 2m minus 3 x squared plus 5m minus 1x plus 3m minus 2 equal to 0 has 2 solutions. Okay, so it has 2 solutions. So if it has 2 solutions, that means we have to use a formula which is called discriminant. So 2 solutions means b squared minus 4ac more than 0. More than 0. Okay, so this is a formula actually. Let's do a quick revision on all these formula. So if you have b squared minus 4ac more than 0, that is 2 solutions. If you have b squared minus 4ac equal to 0, that is 2 equal solutions. If you have b squared minus 4ac less than 0, that is no solution. So basically we have 3 situations. Okay, so these are the 3 situations. And now let's continue with this. So the 2 solutions here, I assume the solutions are 2 different solutions. Okay, 2 different solutions, then this is the formula. 2 different solutions. So if there are 2 equal solutions, then this is the formula. Okay, so of course there is one more situation where they mention there are 2 solutions without saying that they are equal or different solutions, and then you can use this scenario if they don't mention clearly. Like we can use b squared is the combination of the first and the second. B squared minus 4ac more than or equal to 0. We can use this if they don't mention whether the solution are different solution or equal solution. Okay, so maybe I put it in this way. Okay, so this is two different solutions. Okay, two different solutions. Okay, now you can see we have two different solutions, this formula. Two equal solutions, this formula. No solution, this formula. Combining first and second case, b squared minus 4ac more than or equal to 0. So this is this one, maybe I should put it as two solution then. Two solution. Two solution is where they don't mention whether the solutions are equal or different. Then in general, we just put b squared minus 4ac more than or equal to 0. So let's say for this case, as the question never mentioned clearly, they just say it has two solutions and they never mention whether there are two different solutions or two equal or same solutions. So we assume it belongs to this case then. Okay, we assume it belongs to this case. Okay, so then we use formula. How to use formula? You have to see your A, this is your A, this is your B, and this is your C. We have the A, B, C there. Okay, so A equal to 2m minus 3, B equal to 5m minus 1, C equal to 3m minus 2. Okay, so we are using b squared minus 4ac more than or equal to 0. So 5m minus 1, this is b squared, minus 4a c more than or equal to 0. Okay, then we expand them. Expand, and then we have to solve the quadratic inequalities at the end. Okay, so we expand this. We get 25m squared minus 10m plus 1 minus 4. Okay, this one we expand these two bracket first. 6m squared minus 4m minus 9m plus 6 more than or equal to 0. Okay, so we leave the minus 4 outside, and now we times in. So 25m squared, 10m plus 1. Okay, now I times minus 4 into each of these one by one. Okay, so I get negative 24m squared, 16m, 36m minus 24 more than or equal to 0. Okay, then I simplify it, I get m squared plus 42m minus 23 more than or equal to 0. Okay, so we get something like this. Let's see. Okay, now once you get this, right, so let me double check first. So this is 6m squared, 2 times 2 minus 4 minus 9 plus 6. Okay, correct. Then negative 24, 16, 36m minus 24. Okay, correct. This one m squared, 52 minus 10, 42. 1 minus 24 minus 23. Okay, so once we get these quadratic inequalities, so what to do is we need to factorize it if that is possible, but I know that we can't factorize for this case. So because of that, we have to use quadratics formula. So we use quadratics formula. So a equal to 1, b equal to 42, c equal to minus 23. Okay, then we use quadratics formula. 42, minus b plus minus b squared minus 4ac square root over 2, 1. Okay, so we solve it. Minus 42. Okay, again we press everything in the square root first. 42 square minus 4 times 1 times minus 23. So square root of 1856 over 2. Okay, then we have two answers here. The first one is minus 21 plus 4 sub 29. The second one is minus 21 minus 4 sub 29. Okay, then change it to decimal. 5406. The second one. Minus 42.54. Okay, so we get two values here. Then we sketch the graph. So the first value is minus 42.54. The second value is 0.5406. So since our quadratic inequalities is greater than or equal to 0, so we have to take here and here. So m is less than or equal to minus 42.54, or m is more than or equal to 0.5406. So we take these two values. Okay, then yeah, let's see. Let me double check first. 2m minus 3. Okay, because the values are a bit weird, so I try to double check again. So this is A, B, C. Okay, so b squared minus 4ac. I just make sure I don't copy wrong questions. Okay, yeah, no. Okay, so I end up with this as they were working. Now let's move on. Question 14 then. Question 14. So as you can see here, the question said, two numbers have a sum of 30. Find the maximum value of the product of such numbers. Okay, again, this is a problem solving. Two numbers. Okay, so let's say question 14. I put it at the side here. I have x and y as my two numbers. So they said two numbers have a sum of 30. So that means x plus y equal to 30. Equal to 30, yeah? And then find the maximum value of the product of such number. Maximum value. Okay, so which means we want to find the maximum of xy, product of such numbers. That means we have to times them. Find maximum of xy. Okay, so what we need to do is we use the first equation here. We change it to y equal to 30 minus x, and then we substitute into this one. So the xy is equal to x 30 minus x, which is actually a quadratic. 30x minus x squared. Yeah, it's a quadratic. So there are many ways to solve this. The easiest way that I can think of is by sketching the graph. So as you can see, from here itself, I know that these quadratics expressions will have two roots if this equal to 0. So the roots are 0 and 30. 0 and 30. So the graph is going to be like this. So it has 0 and 30 as the roots, and then it will have 15 as the maximum. 15 as the maximum, which is in the middle. So I take 0 plus 30 divided by 2, then I get 15. So to find the maximum of xy, right? So we basically put 15 over here and there, then you will get the maximum. We have to find this value actually. Okay, so let's continue with this then. So I substitute x equal to 15 into x 30 minus x, then I will get the maximum. So where I put 15 inside, so it will be 15. Okay, I write down first the maximum value is equal to 15 30 minus 15, so which is 15 times 15. Okay, so we have 15 square here, so at the end 225. 225 is the maximum value. Okay, so finish all the question there. Okay, so let's continue with question 15 then. Find the rule of the quadratics function which describe the graph. So when you look at the graph here, first you can see that is a minimum point given 1, 5. If they give us minimum point, right, basically we can put our quadratics function in the completing the square form. You see in general it's like this, x minus p square plus q. So this is completing the square form. So if you have minimum point, then you just put the 1, 5 in this way, x minus 1 square plus 5. Okay, so we have to put it in this way. If you still remember what we learned before, that time when we have done completing the square, I do something like this. I let the bracket equal to 0, and then I get x equal to 1. Then I say everything here is y. So y is equal to 5. So 1, 5 is the minimum point. Okay, so which is this point, 1, 5. So now if they give us 1, 5, then you have to put it in this way. So put minus 1 for this and put 5 straight away for this. And we have the a here, and to find the a, we use the point here, 2, 10. So we use 2, 10, we substitute here and here. Okay, so let me write down first. So substitute 2 and 10. Okay, so y is 10, x is 2. So 10 equal to a plus 5, a equal to 5. So we get a. Then after that, y equal to 5, x minus 1 square plus 5. So we can just leave it as this. Okay, so this is the answer for question 15. For question 15.
Yeah.
Now let's look at question 16 then. Question 16. Find the coordinates of the point of intersections of the graph with equations. Okay, so we want to find the point of intersections. They give us 2 equations. Okay, so basically what to do here is we have to do simultaneous equation. So question 16, we have question 16a, we have y equal to 2x plus 3, then we have y equal to x squared. Okay, so we put it as equation 1, equation 2. Okay, now what to do is simultaneous equation. So we can do it like this. We can let 2 equal to 1, so that x squared equal to 2x plus 3. So we let these two equal to each other, basically. This equal to this. As they are both equal to y, right? So I let them equal to each other. Then I get this. And now I need to change it to a general quadratics form. Like this. And then I factorize. I'm going to think of two numbers that multiply to get minus 3. And two numbers that add up to get minus 2. So I choose this because I know when I add up minus 3 and 1, I will get minus 2. Okay, so we have to factorize it in that way. So we have x minus 3, x plus 1 equal to 0. So x minus 3 equal to 0, x plus 1 equal to 0, x equal to 3, x equal to minus 1. Yeah, so these are the two x coordinates. So we need to find the y coordinate as well. Now we can use equation 1 or equation 2 to work it out. So let's say I use equation 2. So y equal to x squared, right? So I substitute the x as 3, yeah? So 3 squared. So y equal to 9. So equation 2 again, y equal to x squared, y equal to 1. So I have 3, 9, and I have minus 1, 1. So these are the 2 points of intersection. Okay, 3, 9, and minus 1, 1. So this is 16a. Okay, now let's say 16b.
Okay.
Y equal to 8x plus 11 and y equal to 2x squared. Equation 1, equation 2. Okay, now again we let 2 equal to 1. 2 equal to 1. So we substitute 2x squared, 8x plus 11. Substitute like this. Then we bring everything to one side, to the left. So like this. And now we have to try to factorize this. So let's see, I check with calculator first. Where I think this one cannot be factorized. I just want to double confirm with calculator. Yeah, so we can't factorize this. So sometimes our quadratic equation can't be factorized. That means we are not able to put it in two brackets. So that is what I mean by cannot factorize. So this is the case where I can't factorize. Okay, so I have to use quadratics formula then. Okay, so which means I have a equal to 2, b equal to minus 8, c equal to minus 11. So I have to use this formula, minus b plus minus b squared minus 4ac square root over 2a. Okay, now let's see, x equal to, okay, we have minus b, yeah? Minus b means minus negative a plus minus b squared minus 4ac square root over 2a. Okay, then we count this. We start from the calculation of everything in the square root. We have 64 minus 4 times 2 times minus 11. So we have square roots of 152. Square roots of 152 over 4. Okay, then we have to separate them. We will get 5.0822. So the other one, we get negative 1.0822. Okay, so we get two x values. So this is 16b. Okay, now let's continue. 16c then. 16c. So we have y equal to 3x squared plus 7x, and we have y equal to 2. So equation 1, equation 2. So let's say we let 1 equal to 2. So we will have 3x squared plus 7x equal to 2. 3x squared plus 7x minus 2 equal to 0. Okay, we have this then. And after that, okay, now we try to factorize it. Okay, so again, I will just check with calculator to see whether factorization is possible or not. So we have 3, 7 minus 2. Okay, so again we can't factorize. Of course, when you press calculator, right, so your calculator will show cert form, will show something like this. Okay, the calculator shows something like this, or certain calculator will show decimals. So if they show cert form of decimals, that means you can't factorize it and you have to use quadratics formula again. Okay, so our values: a equal to 3, b equal to 7, c equal to minus 2. Okay, now we use quadratics formula. X equal to minus b plus minus b squared minus 4ac square root over 2a. Okay, now again we count everything in the square root. So 7 squared minus 4 times 3 times minus 2, square root of 73 over 6 so we get 0.2573 minus 2.5907. Okay, so we get two of these as the intersections. Oh yeah, I forgot to find the y also. Okay, for 16b as well as 16c, I need to find the y. So let's pull it back. Let's come back to questions 16b first. You know, after you get the axis value, and then you have to find the y to represent the coordinates. So now I forget about the y part. So I put it back to equation 2, let's say. Equation 2. So y equal to 2x squared. Okay, then we will get 2 times 5.0822 square. So we get 51.6575. Okay, so this is one intersection point. Okay, and on the other side, equation 2, y equal to 2 2 times negative 1.0822 square. So we get 2.3423. Okay, then we get negative 1.0822, 2.3423. Okay, so these two are the intersection points. And let's come back to question 16c then. 16c, once you get the x value, for the y value we can just take 2 straight away, as it is fixed, y is 2. Okay? So the intersection points is hence 0.25732 and negative 2.59072. So these two are the values. Okay, so let's see the next question. Question 16D then. 16D. So 16D, we have y equal to 2x squared, y equal to 2 minus 3x. Okay, so we call this equation 1, equation 2. Okay, then we let equation 1 equal to 2, 2x squared equal to 2 minus 3x. Okay, then we shift everything to one side, 2x squared plus 3x minus 2. So you can see I shift everything to the left, I get a quadratic equation. And now we need to try to factorize it if that is possible. So the best way to determine is to check with calculator. Okay, so we can factorize for this case. So we have 2x multiplied with x to get 2x squared. Now I have to get positive 3, and I think of two numbers that means I'm going to do something like this. So 2x times x equal to 2x squared. And I'm going to think of two numbers that multiply to get minus 2. And at the same time, when you cross multiply with 2x and x, you have to get positive 3x when you sum up the product. Okay, so let's put it in this way. Minus 1 and 2 cross. Okay, so minus x, 4x. You add them up, you get 3x. Okay, you get 3x. Okay, now that means factorization is successful here. So we get the factors by looking at this and this. Okay, then we write it in this way: 2x minus 1, 2x minus 1, x plus 2. Okay, then we let 2x minus 1 equal to 0. Then we let x plus 2 equal to 0. So x equal to 1 over 2, x equal to minus 2. Yeah, so we get two of these x values. And equation 1 then, y equal to 2 half square. And then we count this, 1 over 2. So 1 over 2 and 1 over 2 is the first intersection point. And the second intersection point, we use equation 1 again. We substitute minus 2 inside. So we get 8. Minus 2 and 8 are the second intersection points. Okay, so we get the two intersection points. Okay. Okay, so let's continue this number 17 here. Question 17. So again, this is another problem solving. A parabola has x-axis intercept minus 4 and 1, and it passes through the point minus 1 minus 12. Find the rule for this parabola. Okay, so what we can do here is, since they give us the x-intercepts, so we can put it in this form. I write y first. Y equal to a, x plus 4, x minus 1. So the reason that I have this is because you see the x-intercept is minus 4, so I change it to x plus 4. Then the other x-intercept is 1, then I change it to x minus 1. Okay, then the a value I need to find out afterwards by using this point. Okay, so now I use minus 1 minus 12. I substitute into the quadratics on top there. So I will have minus 12 equal to a minus 1 plus 4 minus 1 minus 1. Then I have a 3 minus 2 minus 12 equal to minus 6a, a equal to 2, a equal to 2. Yeah, so once I get 2, then I'm going to put it back to the first equation, y equal to 2, x plus 4, x minus 1. So I get y equal to, expand it lah. You can leave your answer like that or you can expand it. So x squared 4x minus x minus 4. Then we get y equal to 2, x squared plus 3x minus 4, y equal to 2x squared plus 6x minus 8. Okay, so we have the quadratics equation ready. So this will be the answer. And now let's look at B then. 17b. So the questions. The coordinates of the turning point of a parabola are minus 1, 3, and the parabola passes through the point 1, minus 5. Find the rule for this parabola. Okay, this is going to be another techniques where we have to use the form after completing the square, and because they give us turning point minus 1, 3, so we have to use this form, y equal to a x minus p square plus q. We have to use this form, and our turning point is minus 1, 3. Turning point minus 1, 3, we put inside, it becomes x plus 1. You see the x will be opposite sign. The x coordinates there is minus 1. When I put into the bracket, it becomes x plus 1. The y is 3, and this becomes positive 3. The y will not affect the plus minus. The x will change from minus become plus, but the y remain as 3. So now I have this form. I have this form ready. So this and this come from the turning point. Okay. So then we need to find the a also, as it passes through this point 1 and minus 5. So we have to substitute into the x and y there. So I put it in this way. Use 1 and minus 5. So the x is 1, the y is minus 5. So I put it in this way. A 1 plus 1 square plus 3. So 2 square, which is 4a minus 8 minus 2. Okay, y equal to minus 2, x plus 1 square plus 3. Okay, so we get this form. We can put this as the final answer. And now let us look at C then. Look at C. A parabola passes through the point this, and this. Find the rules for this parabola. Okay, so this is going to be more working to do. Let's say I do it here, 17C. So we don't have the x-intercepts, where if you have the x-intercept, you can do like this. This is the first technique basically. If you have the turning point, then you can do like this. This is the second technique. Now the 17C is going to be the third techniques. Okay, so you see how we have 1 minus 3, 0 minus 3, minus 1, 1. Okay. This point is obviously the y-intercept, because it's 0 something, right? It's y-intercept. So when we set up our quadratic ax squared plus bx plus c, right? So you need to know the c is the y-intercept. So because of the information available here, minus 3, which is the y-intercept. So this c can be minus 3 straight away. So y equal to ax squared plus bx minus 3. Minus 3. And okay, so once we have this, then we have to find a and b. We use 1 minus 3. 1 minus 3, yeah? So x is 1. We put 1 here and here. Y is minus 3, we put here. Okay, then we substitute. And we get minus 3 equal to a plus b minus 3. A plus b is 0. B equal to negative a. Okay, then I can use another point. I have this point as well, minus 1 and 1. I substitute here and here again. So I just write it down first. Use minus 1 and 1. So I substitute y, this y, I substitute with 1. And the x's here, I substitute with minus 1. Okay, so 1 equal to a minus 1 squared plus b minus 1 minus 3. So then I get y equal to a minus b minus 3. So I have this equation 1, this equation 2. And then I have to do some simultaneous equation. So I can substitute. Okay, substitute 1 into 2. Okay, substitute 1 into 2. Then 1 equal to a minus negative a minus 3. So 1 equal to 2a minus 3. 4 equal to 2a. A equal to 2. Okay, I get a already. I get a equal to 2. Then equation 1, b equal to minus 2. Okay, so I get a and b now. A is 2, b is minus 2. Okay, so once I get a and b, right, I pull it back to the quadratic equation here. This one, a is 2, b is minus 2. Then y equal to 2x squared minus 2x minus 3. Okay, so we get this. This will be the quadratic equation. So altogether, you will realize there are 3 techniques. The first technique is they give us x-intercept. Then we use these ways. The second technique is they give us turning point. Then we use this way. The third technique is they don't give us turning point and x-intercept. Then we use this way, simultaneous equation. So there are altogether three skills to form the quadratic rule. So that is question 17. Okay, now let's look at question 18 then. Question 18. So this question, again, this is a problem solving, obviously. So the surface area of a cylindrical tank with a hemispherical top is given by this formula S equal to this, where A equal to this, B equal to this. What is the radius of a tank of height 6 meter, which has a surface area of this? Okay, so which means we have to use these equations. This is the equation. They give us height 6, surface area 125.6. Then we need to find the R. So we need to find the R. So okay, let's do it at the side here. question 18. S equal to AR square plus BRH. They give us A, 9.42. So I substitute inside 9.42 R square. They give us B, 6.28 RH. Okay, now they give us height equal to 6. They give us S, the surface area. Surface area is 125.6. Okay, now what to do is we just substitute into the equation 125.6, 9.42 R square, 6.28 R times H. H is 6. Okay, then we'll get a quadratic actually. So let's say I just handle this first. 6.28 times 6. 6.28 times 6. So I get 37.68 R, 9.42 R square, 125.6. Okay, 9.42 R square, 37.68 R minus 125.6 equal to 0. Okay, so we get these quadratic equations. So of course, most probably this can't be factorized. So I just check with calculator. Okay, so to see whether we can factorize or not. If cannot, we use Quadratics formula.
Okay.
Yeah, so yeah, cannot factorize. Okay, so I use Quadratics formula in this way. So our A is 9.42, our B is 37.68, then the C is minus 125.6. So we use R equal to minus B plus minus B square minus 4. Okay, not enough space. Maybe. Okay, I write again here. R equal to minus B plus minus B square minus 4 AC square root over 2A. Okay, then we just press everything in the square root first. 37.68 square minus 4 times 9.42, 125.6. Okay, so negative 37.68 plus minus 6152.3904 square root over 2 times 9.42, 18.84. Okay, now we get R equal to 2.1633. That's the first value. The second value is negative 6.1633. Of course, this value we are going to reject because this is a negative value. Radius has to be positive. So at the end, we take 2.1633 as the final answer.